Hey Forkers, this is our first live in-person episode. We actually sat down at a physical table with microphones and we hit record. It was great to do that just in person in general. We recorded it at Scale in Southern California Linux Expo, and thank you so much to the Scale team for letting us use the media room, and thank you to Mark for coming on the podcast and chatting with us. We had so many cool topics to talk about that usually for any episode, we get a good amount of maybe 10 to 15 clips from the episode that we share on social media. This podcast has over 30 clips. There were so many moments that I just wanted to share that we clipped it all out. We're sharing it on social media channels. Please go there to follow along and share the clips with other people and just listen and enjoy. We talk a lot about AI and the future of software engineering and infrastructure and security. I think you're going to like it. So sit back and enjoy this first ever episode that does have a few audio hiccups, but hopefully you don't notice them because we had some great editors on this show. Can you believe it? This ad spot is available. If you're interested in reaching this audience, interested about infrastructure and engineering and security and cloud and all of these things, reach out to us. We have ad spots available, including current packages with some great guests coming up, as well as the back catalog, which also has some amazing guests and people and topics. Go to the URL fafo.fm/sponsor. You'll see all the packages there. We can get you set up. Literally, if you sign up for one, we can put you in this episode before everyone downloads it. So reach out, let us know. We'll talk to you soon. Welcome to Fork Around and Find Out, the podcast about building, running, and maintaining software and systems. Welcome to Fork Around and Find Out. I am Justin Garrison, and this is a very special, our first in-person recording with anyone. We are at Scale 23X. I'm here with Autumn Nash, as always. Welcome, Autumn.
So excited to be at Scale. It's Nerd Summer Camp.
It is Nerd Summer Camp. And our very special guest, Mark Russinovich. Thank you so much for joining us.
Thanks for having me.
CTO of Microsoft Azure.
That's right.
You have a keynote tomorrow, and I want to go all into the details and what you're talking about. I actually really want to do one thing as a personal thing first, where I know you are very famous for Windows System internals. Uh-huh. I read your 0-day book that you published 12 years, 13 years ago. Yeah. You have a series of books, but I don't think a lot of people know about. I listen to them. I listen to audiobooks, but I only buy physical books when I have met the author in person. So if you wouldn't mind signing that, I would love it. I literally just read it again last week to refresh my memory on the book. So 0-day, source code. What was it? There's 3 of them.
0-day, Trojan Horse, and
that was
Rogue Code.
Rogue Code. That was it. And it's all Jeff Aiken. Jeff Aiken, man. Yes. Yeah. Man, I just read it and it's, I love them. It's super fascinating, especially thinking back that was 13 years ago. And you were already talking about a big warning that I took the second time listening to it was what happens when we lose control of technology? What happens when we don't have the manual? What happens when we don't know what's going on? Yeah. And that was a big warning out of this book. How does that play out in 2026? When people...
I think it's going to play out.
Yeah. Like, how do we get back to that? How do we get back from that of this might be worse, right? Like more people don't know what's going on and they're trusting computers even more of, every warning in the book of like, yeah, you don't have manual controls to turn off the reactor. What's going to happen?
Well, I think, when it comes to reactor, people putting in good mitigations and fallback systems for something like that. It's kind of the everyday stuff. Like, that when the airline baggage claim system goes down and that all travel around the world starts to stop because London Heathrow's baggage claims aren't working. Yeah. Or the airplane routing system fails and that can't come back. I mean, one aspect of this is that when it comes to those kinds of failures, which have typically been due to configuration issues or bad rollouts or overload of some kind, is that we've got a lot of mechanisms in place that we've developed over time to be resilient to those kinds of problems. Mm-hmm. So, and those patterns are going to become more and more ingrained in the systems as they get built, rather than everybody having to go make it up every time as they design something new. So I do see hope when it comes to our systems getting more resilient. The risk, I think, is that the systems are getting just incredibly complicated.
Yeah.
And if you take a look at any one of those failures on those large scale systems, it's usually not just one problem that happened. You know, especially when I look at failures in Azure, it's not one issue, but it's actually this issue happened, and this issue was going on at the same time, and this other issue took place. It's like
the combination of this,
that all just
perfect
lined
storm.
up. And that's just because the systems are so complicated, and it's hard to design to defend against that.
Is simpler systems the answer?
I don't think they can be simpler. You know, this is kind of takes me to when I'm designing something in Azure. I've been designing things with people in Azure, and you present other people the design, and they go, "Wow, that's really complicated." And I'm like, "Okay, where can you simplify it?" Because I think it's as complicated as it has to be. Yeah. Because there's lots of problems that are just inherently complicated, and so you don't want to overcomplicate things, but at the same time, there's some floor to the complexity that you can't get beneath. Otherwise, you can't solve the problem.
Especially at a certain scale.
Yeah.
Yeah, it's like solving simple problems can be simple, but I always tell people that like the most complicated system I've ever seen was the back end of Lambda, right? Like when I worked at AWS and I was just like, oh, this is so easy to use. What's the back end? I'm like, oh my gosh. Yeah. Like that's people, I work on Kubernetes and people were like, Kubernetes is complicated. I'm like, people can build some really complicated stuff, but the interface can be simple, similar like a car, right? Like look under the hood and like nobody knows, you know, like what percentage of people can actually fix what's under their hood today.
And there's an abstraction up at the front, which is put it in a drive. Yeah. And it just goes. Yeah. You know, press your
put in gear,
foot on the
steering
pedal,
wheel,
right?
and hopefully you might use a blinker.
Yeah.
Do you think abstraction is going to be what makes the risk bigger? Because I think like when you look at the abstraction of cloud, when people forgot that it was just a bunch of Linux servers, like I think we keep extracting away. And I know that we obviously don't write assembly anymore, but not all the time, but I feel like sometimes when you get farther and farther away and have less context, it gets to the point where you don't fully understand how it all works. So like, how do you see us kind of navigating this new abstraction and high velocity in which that we're going to be working with AI?
So first, I think these layers of abstraction, we've been growing them layer on layer over time. And we reached a kind of levels of abstraction that are too deep for one person to really understand everything. When something happens in Azure, it requires a lot of information to figure out exactly what's happening because it's across multiple layers of the system and different components of the system, all because at the top, there's an abstraction that people do understand. And actually it's kind of funny because Scott Hanselman and I gave a talk at Build together on the layers of abstraction that have built up over time, starting with an Altair where you're programming little lights and now, then all the way to cloud computing, which is, orders of magnitude, layers of abstraction that's been put on top of what started in the 1970s. But I think what you're referring to is the layers of abstraction that's coming into place right now, which is AI, which is another systems or executing tasks when you're doing it with agentic AI. And that layer of abstraction removes us even more. You don't really understand what the LLM's doing or why. I think that we're figuring that out, and I think we will. We'll put in guardrails so that the AI can't go off the rails and do something that it shouldn't do or something that's going to be problematic, as well as enough monitoring and logging to identify when there is a problem and be able to figure out what problem happened. I mean, this is what we've done over time as we build these layers of abstraction. You put in guardrails, you put in logging, you put in systems that understand how to get through that. And in fact, AI is going to help us with that too.
And you think there'll be like a observability moment for LLMs so we can understand? I mean, that's like observability in cloud and stuff is all about understanding the system, whatever state it's in, and being able to do that at an LLM level of right now, we make it work and we don't necessarily like, how did we get this output or what exactly is it doing? Yeah. But we'll be able to observe the state of the system and maybe influence it or at least protect ourselves from it.
Yeah. Or understand when something went wrong, what happened. I think we haven't reached that moment of really understanding because agents are relatively still new and agent frameworks and orchestration systems are still new, and what we're trying to do with them is still new. We're still figuring out what's good for, what kind of problems are good for agents.
How would you define an agent?
AI-based system that makes autonomous decisions.
Autonomous decisions?
To carry out a task.
Okay. How do tools come into that? I've heard people say like it's an LLM with a tool.
Yeah, well, actually they can use, to carry out a task, you have
You need some
you need
tool,
to do, you
some
need to
way
have
to-
some
okay.
effect on the outside
Yeah.
world, outside the system. So yeah, tools would do that,
Okay.
or skills or whatever, calling them CLI or whatever.
Whatever branding we want to put on top
Yeah.
of it. Yeah. An MCP, whatever.
Yeah.
I love the paper that you and Scott wrote together. And I think that it's like the elephant in the room that a lot of people have ignored. And it really gave me like hope when you two really focused on that and were willing to come out and like talk about it, and have the conversation that people weren't having. For people who are kind of like still growing and learning it as developers right now, and even people that are maybe coming in, how do you think that we're going to like how you just said, we're still learning, right? How to use these things. How do we continue to like develop and teach engineers how to like engineer and to grow in the same manner that we were expecting before, but now kind of in this new AI age? Like, how do they still get the context? How do you go from like a junior engineer to a senior engineer in this new world? And like, how do we give them those skills and like mentor and teach them? And because we don't really know like what the senior engineer is going to look like in 5 years, Everything's moving so fast.
Yeah. Well, so the paper you're referring to is one that Scott and I published in Communications at ACM. That's went online. It's going to be in the print issue in April, but it's about what we should do to head off the talent pipeline problem that I think we're heading towards, current course and speed. And backing up, this came as a realization to me early to mid last year, as I started to use coding agents, which showed up in the scene in around February of last year. And as I was using them, I found that my productivity boost from AI assisted coding went from 1.5 to 2x to 5 to 10x. And this
How'd you measure it?
It's, it's very ad hoc.
Vibes.
Yeah, it's vibes. Yeah, it's pretty much vibes.
But still, yeah.
I didn't do A/B testing,
Yeah.
but I did I looked at one of the projects that I made, which was, I've made a whole bunch of projects. One is a Chrome extension that goes and scrapes New York Times WordleBot logs or data to show you your trends over time and to show you individual games. It makes it much more easy to navigate. I've never done a React UI. I've never written a Chrome extension. I've not really written JavaScript. I haven't used Node packages, and this thing is entirely built on that, and it works. And you can go get it from the Chrome store. Yeah. And when I look at that, if I had to do that pre-AI, first of all, I would have to learn those things, and that would have taken me days, weeks, maybe even months to learn to the point where I could understand what I was doing and actually execute it. And the second thing is just the work of coming up with the design, typing it all in. That would have also taken a lot of time. It took me about 2 weeks just part-time prompting to develop this thing. And then another few days of part-time prompting to polish the UX and add some things to it. But again, I think easily that's 5 to 10x. And I say 5, it's probably more like 10, but I'll say 5 just to be conservative because, I don't want to be wrong on the other side of it. But in any case, I did project after project like this where I estimated that my boost was in somewhere in that range. But when I looked at what I was doing, I was micromanaging the AI because the AI was making mistakes, gaslighting me, doing the wrong thing, getting stuck, and I would have to prompt it and guide it and correct it nonstop. And I've been collecting every time I do agentic coding, every time the AI does something ridiculous or incorrect, I grab a screenshot of it. And I've got just dozens. Every time I sit down in a day and I spend an hour coding with the AI, I get at least 1 or 2 more of it's like, what the hell? The test is working when it's not working. The race condition's fixed when there's a sleep statement in it.
I take a note by it and then I add like whatever I can to my Copilot instructions so that way I can get it to stop like falling into the same cycles over and over again.
But you've had to unstick it at times.
Lot, yeah.
And I've just got so many hilarious stories from AI. One of them, and these are all frontier models, like, Opus 4 and GPT-5 and higher kind of stories. One of my favorites was I have it write these tests. Everybody's, got to write the test to make sure it's not regressing and that you understand that things are making forward progress. And the AI can also look at the test and see when it screws up. And at one point I'm like, okay, time to go look at the test. So I go look at the test and one of them, and they're all passing and they print some stuff. One of them, I look at the file and it's just print statements. It's like, if the test was written, it would do this. Like, I was floored by that.
I've had it do things like that too. Like I'm like, let's, copy this test from this open source project so we can try to like build like a POC of a test and first service. And it was just basically copy and pasting it instead of taking it and actually pulling it down. And it just made its own when it was too hard.
Yeah.
And I was like, it's not the same.
Yeah, it is. It is lazy. It'll take shortcuts.
Yeah.
But in any case, what I was realizing is a few things. One, AI was doing stuff that typically early in career, new developers would learn from as they come into a job and they write the unit tests or they fix the bugs. And it's like AI can go do those things now. And so one issue is why even hire junior engineers if AI can do their job? And the second thing I realized as I was doing this is I was getting this 5 to 10x boost because I have decades of software engineering experience. I've learned the hard way by spending hours on some stupid bug that, you finally crack and you're looking all around and trying all sorts of techniques to figure out what's going on. That has given me the experience and insight and what Scott likes to call code taste to be able to push the AI forward in the right direction and unstick it and see through its gaslighting. But a junior engineer doesn't have that experience. Yeah. And in many of the cases that I'd run into, I'm like, I only know that this is wrong because I have done it.
Exactly.
And a junior engineer is not going to know. So they're not only probably not going to get this boost that I'm getting, they might even get a drag.
Yeah.
Because they're going to run into a problem and they're not going to know how to get the AI past it.
Yeah.
And so if the incentives then build up to A, don't hire junior engineers, and B, even if you do, how are they going to learn when they're using AI to write everything and they don't really know what they're doing at some point? I mean, they might get some, and by the way, they're probably getting a superficial boost and there's a lot of AI slop underneath the hood that is going to cause a downstream impact.
And they don't know the difference.
They don't know.
Yeah.
So, if we stop hiring junior engineers, obviously 5 to 10 years from now, we've got a huge problem. But how do you grow junior engineers if hiring them actually is going to slow you down?
I even think it's going to be interesting when it comes to growing mid-level engineers and what being a senior engineer means, because now it's a different type of mentorship on how to grow mid-engineers and how to be a senior engineer,
Yeah. Well, so, and that's a whole different, exploration. But in the first place, I came to the conclusion that the only way to actually keep the pipeline going is the apprenticeship model. We're actually hiring them to grow them, not hiring them to go do the grunge work that now AI is doing for you, which they would normally would have learned from. So how do you make them learn? You can't let them use AI all the time. You got to make them, exercise their brain muscle and learn the hard way. And what reinforced this for me is a few studies that happened early last year. And then other studies that have reinforced that have come out this year. One of them last year is one of my favorite ever, which really shows it. The impact on AI, something that the researchers call cognitive deficit. Mm-hmm. It's a study from MIT where they took 60 Boston area adults and gave them all SAT style essays to write. And they divided them into 3 groups. One group, closed book. They just had to write the essay. The second group could use Google search. And the third group could use ChatGPT to write the essay. And they monitored using functional MRI their brain activity as they were writing it. And then they quizzed them about their essay an hour after they wrote it and a week after they wrote it, and I think a few other times. And it's exactly what you would imagine. The people that wrote it, closed book, lots of brain activity.
They knew what they wrote.
Yeah. And a week later, they're like, here's exactly what I wrote. Yeah. The people that use ChatGPT, almost no brain activity, and they couldn't even remember an hour after they'd written the essay, what they'd written.
Yeah.
And isn't that slowing down on purpose, like that's the thing that helps like organizations scale and remember, like as an individual can do it. Like if you're a junior and you actually write the code, I remember this when like Ruby on Rails came out, right? Like Ruby on Rails accelerated how fast I could ship an app because it just did a bunch of the grunt work. I'm like, oh, cool. I just put in a couple things that are my app and it's on this, file-based routing and it all just works. I don't remember how it works under the hood, but it made a bunch of decisions for me. And I was moving fast, but now I can't tell you how that worked back then, and also happens at organizational level, where if you have junior engineers, they do force you to slow down, and a senior engineer has to mentor them and train them and bring them up to speed on, this is what this outage feels like. This is why that code won't scale beyond 10,000 users or something. And slowing down on purpose to say, hey, actually at an org level, we need to make sure that we're bringing everyone along. It feels to me like a little bit like DevOps back in the day, where you're like, hey, we want to cross-pollinate and train everyone to make sure everyone kind of like ops people and dev people, they know how to write code, they know how it runs, they know why the decisions are being made, and we want to become learning organizations. And now we just want to be shipping organizations. We're just like, just move as fast as you can, we don't care. But that cognitive like disconnect of like, well, how does it run? What does it do? No one cares anymore.
I also think a little bit of trauma goes a long way, right? Like if you like drop a table, you're never like doing whatever you did before. But like, how do we incentivize senior engineers or other people to invest in teaching? You know what I mean? And like, I also think it depends on how you use AI. Like there's like Claude thinking, there's different ways that you can have it. You can have it give you multiple options on how to solve something and then go pull the sources. And you know what I mean? Like there's ways that you can get to a lot of the planning and requirements, so you're still using your brain without going straight to like, go do this thing for me. How do we like teach that?
Yeah.
You know?
So Scott and I proposed this program we call preceptorship. Scott's wife is a nurse. In the nursing profession, they have a form of apprenticeship called preceptorship. And there's nurses that are designated preceptors in the hospital. Their job, one of their primary job functions, is to bring up the junior nurses, to coach them and guide them and observe them and help them out. And so we believe that the way to get through this is to identify senior engineers that like to teach, that feel like they get energized by that and they're good at it, and designate them as preceptors, and then assign early in career developers to them where they're then being guided and coached. And this doesn't mean 24/7, but it means, probably at least one day of time a week spent with the junior engineer over their shoulder, watching them, coaching them, and then also giving them tasks to go perform. And I think what's ultimately going to happen, and on top of that, to help this, is AI assisted teaching to the junior engineer, which is, like you said, instead of the junior engineer saying, here, go write a piece of code that does X, Y, and Z, the AI, instead of doing it off the bat, is going to say, well, how would you architect that?
First, you give me the pseudocode and I will fill in the gaps, kind of thing.
And I think that's going to be like so important, because it also means that you can scale the learning too. You can do that at a much higher scale, and it can be more accessible to people.
Does that work in nursing because of the life critical, like there's lives on the line literally? So like we have to have, it almost seems like there needs to be regulation around that.
Well, I think, I don't know about regulation, but I think what's going to happen is there's going to be a transformation of the university company corporate relationship when it comes to training, where incentives get aligned and there's joint teaching happening coming out of school into industry, where if you take a look at hospitals and medical, and this is reflected in other apprenticeship type fields as well, there's designated teaching sites. And those teaching sites, what they'll do is that somebody that goes to those teaching sites and goes through a program like a residency, internship, or whatever, gets some kind of certificate or diploma that is valuable on the market. And they're also then incented to stay at that place that they learned through different incentive structures.
Is this just an AI boot camp? I mean, like we had coding boot camps to get people those certificates, and at some point they became not valuable to enterprises because they actually were worthless. They weren't teaching people the things they needed to learn. And I don't know if one exists today, but I'm sure there's going to be one that's like an AI will train you and give you a cert. But we have to keep it valuable. We have to make sure that they actually know what they're doing at the end of the day.
That's right. It can't be a cert. So boot camp, I think, doesn't reflect the depth of what's required here, which is a program that's probably at 2-3 years in length of doing this kind of stuff.
30-day boot camps is not enough.
As somebody who has a college degree but also has an apprenticeship and how they got into tech, I think we should have always been doing tech apprenticeships, because it is more of a like skill that you're learning. And a lot of the ways that college teaches coding and being an engineer are not the same as what you do at like work. And it doesn't teach Git. They don't teach a lot of the very like important parts of being in the workforce, and being able to actually work with like other engineers and solutions architects and see how it all works and what it's like in production in real life. I feel like that's such a valuable skill. And it's wild because for a long time, like I did an apprenticeship with AWS, but there was funding through Washington and Virginia and all these other like apprenticeship like budgets, and you get to go in and work and do the actual thing. And I feel like I learned so much more from my apprenticeship than I did my college degree.
It's one of the things I love about a conference like Scale, right? Like a Scale is volunteer run. It's completely volunteers. And like, look at the networking gear we have in here. Like this is like literally enterprise grade temporary networking that like, if you go down the hall to the NOC here, these people are experts in their field and they'll take on anyone to say, hey, I just need you to run cables this year. And maybe next year I'll let you program the switch. And the year after you're going to do the Wi-Fi, you know, whatever. They're going to get that apprenticeship in a volunteer setting. I feel like conferences going away and becoming a lot more commercial in that they're just like, we're just going to hire the venue to do all this stuff.
That's why this is my favorite concept.
Right. Like the hacker feel of this, the community feel of it, I don't get it many places.
I learned so much more here. And but I think that democratizes the opportunity to get into tech, and it ends up giving us the most curious people, the people that aren't just from a certain background, but people that are genuinely interested. Because when you have apprenticeship programs and it's not this high cost or fee to get into something, and it's not just like the resources you have, but your like curiosity and the work ethic that you will do in that apprenticeship, it not only like democratizes the access to those things, but it brings in the diversity. Like a lot of, if you look at like Harvard Business Review, when it talks about like why diverse perspectives build better software and like having people from different backgrounds, apprenticeships feed that model. They also like change the way that like you interact with the world, right? Because you're bringing in these different people. Like we had people with PhDs in our apprenticeship program. We had people from all different backgrounds. And who do you see around Scale? Like Casey has a theater major. Yeah. You have, was it science or math?
Physics, yeah.
Like, you know what I mean? And some of the best engineers I've ever met have these different backgrounds, and they bring that
software.
Yeah. And they bring that problem solving, that curiosity, that knowledge, and it's wonderful.
The curiosity, I think, is one of the is the curiosity piece is my favorite part of AI, where AI lets me follow my curiosity better than anything else I've had in the past.
It's cheap and fast to go in through several different ideas. You know what I mean? You can do 3 different proof of concepts and see why one goes wrong. But I think it's the nature in which you use it. Like, are you using it to be curious, or are you using it to be lazy? Because we're all humans. That's human nature, right?
Yeah, well, and the incentive structure has to be there, right? I mean, if you're incented to move fast, you're going to move fast and cut corners and not do like, you know, you hire a junior engineer and you say, here's a project for you. Do it as fast as you can. You know, we want this tomorrow.
And that's a lot of the pressure.
This ticket is one t-shirt size. Yeah. You do it now.
That's right.
And that's a lot of the pressure too. Like, I think everybody, like, so many people are vying for jobs, and the job market is really bad, where like people just want to do well. And, you know, we're really over indexed on efficiency and doing more with less. And I think we're losing a lot of the teaching part, which is really interesting, because do you think this now changes the skills that you need to be a good engineer?
I actually don't. I went back to Carnegie Mellon, the school that I went to, and when I was in the fall, and after I'd already thought about some of these ideas, and of course the day I spent on campus talking to faculty and staff and students, the question was, what's happening to software engineering? Is it going away? What's happened to university? You know, people are talking about going right out of high school into the software industry.
Wow.
Skipping college altogether. Is that?
Yeah.
And the way that I look at it, again, going back to the experience that you've got with AI and that I had, is you need to know what you're doing to make the most use of this tool. And this bet on AI is going to be magical and it's going to solve all the problems and work 100% of the time. I think that's a foolish bet to make. And I don't see a line of sight from where we are with AI and this current technology to AI just gets it all right.
Yeah.
Again, these are frontier models that we've got. And they're doing a lot of brilliant things, but they also make a lot of mistakes. They just don't have the big picture.
I think I meant more of like, do you think it's going to have more of like the interpersonal skills and like because I think
raw coding doesn't matter.
Because we all knew that like coding is the easy part of doing that job 90% of the time. Like, and we always say that you need to get requirements and you need to be able to work together. But I feel like a lot of times when it comes to like hiring people, people just want really technical people. And I think that this almost democratizes the access to being able to learn if it's used in the right way and if we're giving that access. And I wonder if it makes you being a whole person and that curiosity and that ability to work with others and that ability to like experiment and be wrong and, you know, really like kind of just grow, like growth be more important, you know?
I think so. For one, I think it's always been the case that you need to be really successful.
Yeah.
You need to have interpersonal skills. You need to have empathy, and you need to be able to.
Making me so excited. I felt like I was like so sad about tech, and like I was reading about you today and yesterday, and it's like I'm genuinely like really excited to have you as our CTO because you're saying the things that like I think we all think quietly, but like you are willing to put yourself out there and say the elephant in the room, and that makes me like so excited. Like you're just reading about you, like you enjoy solving problems and like researching and writing but like writing professionally in technology, but like, you know, like you're a whole person, and that like gives me hope that like we're going to go in the right direction, because I think like we will get some sort of something from AI, but I think the companies that will truly be successful are going to be the ones that are looking at this whole pipeline issue and this issue as a whole and how to use it as a process and truly make it a part of the process. And it's really exciting to see like not a lot of people will say that out loud.
Yeah.
And really put their money where the mouth is to like figure that problem out. And I just think that is like so
because
rad.
the incentive's not there.
Yeah.
Right? They don't reward.
But that takes bravery though.
Yeah.
Like you could totally just be like every other CTO and just be like, oh, whatever. Like AI is going to solve all the problems. So I just think, no, but that's true.
Yeah.
Like
plenty of layoffs and
it's plenty of people. Exactly.
Yeah.
And I think for you to like come out and say that and to do the work of that paper and to truly think about those things, like is kind of like, it's not happening. People are not doing that right now. So I just think that just gave me like a hope and excitement that like maybe we will all be okay, you know? Yeah.
I mean, to that, you know, talking about the need for people to have interpersonal skills to be successful, you know, these companies are made up of humans that need to decide what to do. You know, it's collective group. Yes, you've got leaders at the top that are trying to get the company to move in some direction. The most effective leaders get people energized about what they're doing. Mm-hmm. And you need to, you know, typically have interpersonal skills to actually get the most out of people. Yeah, you can hire people, and if they don't like you as a boss, they're going to, you know, clock in, do some crap, clock out. But the way you get the most out of people is if they feel like they're part of a good mission, they're heading in the right direction, they're making a difference. One of the things that I've heard other people saying, I think it's true, and I run into this all the time, is like technology would be easy if it wasn't for the people.
Yeah.
Hey, this is Seth Elliott with RPO. That's ARPIO.io. I was the global reliability lead for AWS, and I've worked with hundreds of customers on their AWS and Azure disaster recovery and ransomware recovery strategies. Now, cloud providers offer good tools to make backups. When it comes to actually implementing disaster recovery, things can get complex pretty quickly. How will you recover your infrastructure, your networking, your security, or think about your Kubernetes cluster, recovering that cross-region, cross-account with all your manifests, configuration, and persistent volumes. This is where RPO comes in. We recover not just your data, but everything you need to run your complete workload, even across multiple stacks. This is beyond backup. It's complete recovery, cross-region, and cross-account. RPO intelligently understands your cloud workloads on AWS or Azure and stands them back up in a safe recovery location to meet your recovery point and recovery time targets, regardless of the disaster scenario. So check us out at arpio.io/FAFO and get a free disaster recovery consultation and RPO trial today.
Yeah.
Do you buy into the single person company sort of AI, bunch of AI agents doing all the business stuff behind them? I don't know if you listen to Shell Game podcast, where he built literally like a startup that was just him and a bunch of AI agents, and they literally would like send themselves emails and like Slack messages and like plan stuff. And they had one of them that was all of them had a role. It was like they had a CEO and a finance person and a coding bot or whatever. And then he just organized them and said, hey, we're going to do this thing. Occasionally he'd show up for meetings, and then like they would do stuff. And I'm like, that it feels so weird, but also I know people are rooting that on, and that like just doesn't feel right to me.
Given how off the rails AI can get, I don't know if you saw, Anthropic's run a couple of simulations where they have the AI try to have it run a vending machine company, and they end up doing horribly. The one was like giving people back money.
Yeah.
The first round. The second round is trying to scam people.
One tried to like rat on the fake CEO and his affair that he was having, scrubbed through all of it, and then like tried to hold it over his head so he wouldn't turn him off. Yeah. One actually went after a maintainer and then like tried to put a hit piece out on the maintainer that wouldn't accept its code.
Yeah. But and you
but I mean,
say
CEOs
that we're
also go off the rails too.
that's true. But I again, going back to, how capable are these things going to get? So one thing, ultimately they're in service of humans, right? They're not in service of AI. And if they're in service of humans, they need to understand what the humans want. And if you're letting the AI run off on its own, you can't guarantee that it's going to be doing what you ultimately want. This is, when I'm watching it code and I'm like, no, that's not what I want. You're off the rails.
And that's the hardest part of engineering, is making sure that you have the right requirements to build the right thing, So I feel like
I'm still waiting for the article to drop where an AI implements its own like security encryption, like the thing you never do in writing software.
I'm sure it's happening.
I'm absolutely positive there's exists out there, and we just haven't found it yet.
In which they've been dropping tables, deleting backups, and just completely going.
But it's just someone's going to write their own encryption library. AI is going to vibe code this encryption library, and it's like no, that was not encryption at all. Someone looked at the Wireshark, and it's not happened. So.
But I think on one hand, you see the people like cost of software development dropping to zero. First of all, I don't think it can drop to zero. The more complex systems, the more physics get involved with the development of the software. As you build this complexity, you need to have tests to ensure that the system is functioning as you want, like you want it, and that when you add new functionality, it's not breaking things that were working. Yeah. So, just running the test, that doesn't go to zero. That there's compute cycles that need to execute to make sure your tests pass. Deploying, that doesn't go to zero. So this cost of software development dropping to zero won't drop to zero. It just cannot. And there's also evaluation that doesn't drop to zero either, which is, again, you've got to decide if what the thing produced is what you want. Yeah. And that's evaluation. And you can't have AI be the sole evaluator. You need to come and look at it yourself. Now, AI can help you evaluate, but still you need to apply your human judgment. And the higher the stakes, the more certain you need to be that what you're developing is actually correct and meeting the goals. So long story short, I don't see the single person running a very complex scaled organization with AI bots really working. I could be wrong, but just like I don't see AI, you being able to give it a spec and it's off and make something great that's sustainable and does everything you want.
Do you see the flip side happening? I was like, the end of SaaS is.
Oh yeah, don't get me started about this one. Scott and I had one of our episodes on our podcast about the end of apps and SaaS, and because I just go off and he's like, okay, let's talk about that, because he likes pushing my buttons. But I go, just like this question. The example that I used, and I'm sure you've heard this one too, is like our expense reporting software at my company sucks. And so what I did is I just vibe coded a thing where I just dropped my receipts into this folder. It looks up my calendar. It knows where I was and files my expense report automatically. Look, I vibe coded that. I don't even know didn't look at the code. And look how awesome that is. SaaS is dead. And then that's their conclusion, or apps are dead.
Yeah.
I feel like they just jumped 3 different ships and I'm just like, oh.
No. And I'm going, wait, first of all, there's so many ways to look at this. One, let's say your company has 1,000 employees. You're saying that every employee is going to go vibe code expense reporting app.
Also, how much data did you just give to an age? That just.
The list goes on and on. And everyone has its own set of bugs and security vulnerabilities and compliance problems. The second thing is, you've wasted tons of tokens. And when you could just go and fix the HR app to do that, the right what you want, and do it in one place. And now everybody gets the benefit.
That's what I was going to say. Like, it's the scale in which, like, if you go and you fix it for everyone, is so much better than trying to fix it in these individual places, which is also the value of open source too.
Like, to me, like, the nice thing is the personalization of the software I can write right now, where it's like, I want this tool to do this way because I have some other thing that I like. So, but when you solve it for everyone, it makes it more complex because you have more knobs that everyone has to deal with, right? Like when I look at what happened, like my first IDE was Excel, right? Like I was writing Visual Basic in Excel, and then Excel got way worse. I'm like, wow, this is actually like full blown programming. Like I can do everything in this spreadsheet, which is crazy. But like, maybe Excel didn't need to be that complicated for what some people wanted to do. Like if actually all I wanted was Vim, then I could just do, some.
Doesn't that depend on what you want it to do though? Like
absolutely,
if you, like,
the AI making it more personal to be able to say like, oh, actually, I just want this one thing to do it this one way for me is easier to decentralize.
That's like using
what people want to
like
use.
I use a Mac as my personal computer because I want it to link up to everything else and do certain things for me without thinking about it. But if I'm going to develop something, I'm going to use Linux because I want to know exactly how it's going to like react in that environment. So
and
it's
you
like
have your own development workflows.
That's what I'm saying.
You have
like,
your own plugins.
There's
and your
some
own
things that you like. Look at like Linux and how it's a religion. Like some people want very particular things in it and they want to have access to those things and they want all the buttons. And then there's some people who are like, dude, I just want to get in there, write something and get out. Like, I think if it brings you that value to do it yourself, then you'll spend more time on those things. But if you just need something to get it done.
And I guess that's where like I've been drawing the line at, I won't vibe code anything that I'm on call for. And I won't vibe code anything that's going to like compromise any data that's like private. And so it's like those two things are like, okay, if it has private data or if I have to be woken up for it, I'm not going to let AI touch it or at least not finalize it. But that's just where my personal lines are. And I don't know how that scales to what everyone's doing because it's like an HR app that's like, oh, is it scanning a receipt a bad thing? Like, I don't know. Like,
it's kind of funny though, because you know how like people talk about the relationship between platform and like DevOps versus like software engineering and like, or when engineers get to just give their code to QA, you know what I mean? Like that responsibility and ownership of something, like, because you said you wouldn't want to do it something that you're on call for, right? And I almost think that it shows that you have to like feel the pain of your decisions, because if you can just transfer it to someone else to deal with it, then you're going to just write whatever, but having that ownership of it, knowing that you will get paged in the middle of the night brings a different type of
or
ownership.
if there's a compliance issue in your HR app and you're going to be the one that gets fined for it.
Yeah.
Or, but I just think that this apps or SaaS are dead. There's huge value in centralization. And if you take a look at SaaS, what it is a centralization of a solution to business problems.
Yeah.
And not building the wheel over and over again, which people love to do that sometimes. But I think.
And going back to the complexity thing, like these SaaS apps, if you take a look at, contact management or sales, there's huge amounts of complexity there. Like it looks on the surface like, oh, it's easy, right? Just keep track of your customers and,
also,
in the
if you want
database,
to open a bakery, you want to bake a cake. You don't want to sit here and vibe code a SaaS app for like your customer stuff. Like,
exactly.
You know what I mean? Like that's the point of like, we're engineers. We like doing that. So yes, we want to build it for everything. But like my friend who has her own bakery, probably like, that's not how
it is a very software engineer focused.
Exactly.
We build our own tools. We like to build tools. So
and for that, I mean, it's huge. Like I said, it's like a huge accelerant. I'm like, having more fun than I ever had.
Absolutely.
Coding.
Yeah. I redid my website and I was like, oh my God, I actually might like front end development
the
now.
amount of domains that I was name squatting on domains that actually have something.
I'm actually
there.
using them now.
Exactly. Yeah. It's like I've been paying $10 a year for this thing for how long now?
Stop redirecting to my blue sky now.
Do you have anything specific that you're talking about here at Scale for the keynote? Is there?
I am actually. I love talking about this and the future of software engineering and what we should be doing about it. But at the keynote tomorrow, I'm going to be talking about open source security. Because if you take a look at what's been happening over the last few decades is the world, going to dependency, not just on computers, but open source software in those computers. Microsoft itself, our dependencies on open source are enormous. Much of our platform is built on top of open source, Linux, and we're running Linux in the heart of our infrastructure. Our Office is running on top of a platform called Cosmic, which is running on top of Kubernetes and a lot of Linux. And so the risks of insecure open source are rising, and we've seen more and more attackers come after open source and open source supply chain and try to, that's their way into now the corporate world, is through vulnerabilities and exploits in open source. Not just that, but AI, as we've been talking about, is getting really, really good at finding vulnerabilities.
Yeah. That's scary.
And so we have to take open source security very seriously. And this, one of the things that I helped co-found is the Open Source Security Foundation, which I'm currently chair of. So it's going to be, these are the stakes now. We all love open source. We're all building on open source, but there's a lot of risk that we've got to address in security and open source as an industry. We can't just do it individually. Microsoft can't solve this problem. Even Microsoft, Google, and Amazon can't solve this problem. We need to get the whole ecosystem to solve this problem. And so that's what is the theme of the keynote.
We can't solve that problem with just security signing and
that's right,
making SHAs. Like we have to, like it is a people problem still, right?
Do you think that this incentivizes big companies like Microsoft and Amazon and Google to be better stewards of open source and to really invest in open source?
Oh, absolutely. I mean, one of the things that the three of us have done is fund something called Alpha Omega, create an organization called Alpha Omega Foundation inside the Open Source Security Foundation, which is part of the Linux Foundation. And we've contributed millions of dollars. The goal of Alpha Omega is to go and directly apply funds to help get security improved in major critics, what we consider critical open source projects. And it's proven to be very successful.
How does that practically happen?
It happens with very direct engagements with the projects, like Airstream was one of them. The Alpha Omega went in, met with them, figured out where the money could be applied, what resources they need, contracting, to go and improve the open source security of it and its dependencies. And so this is kind of a great model, but it's only touching the tip of the iceberg when it comes to this. We really need to, and there's something else that's happening too, and that's regulation. I don't know if you've seen like the CRA in the EU, which is focused on, we need transparency into what open source you're using and its security posture. So, and if you're not up to a certain level, you can't use it, which is like going to hurt all of us if we don't get the security up to the standards we need, which we should just be doing by ourselves. But regulation is going to force the issue.
And you think that specifically by having regulation that says it has to meet a minimum bar of security, you can't go use my open source project that doesn't do that. And even if even if it looks fine and it tests fine and AI is like, we publish all the code, it's good. But I still need to have some basic assurances of maybe even like my GitHub account has 2-factor authentication.
Absolutely.
And those are like the bare minimums of this needs to be there. For even to trust the binaries that come out of it.
It's interesting to see a lot of the new tools like Scorecard and like the different ways that people are trying to find ways to kind of give that, build that trust, and with that, this repo is secure and that people are thinking of those things. It's really like just you are what you measure, right? So just having some measurement around it of like, here's the number. I don't care what it's trying to get the accurate measurement. Yeah, but like even think about what you are measuring. You know what I mean? Yeah, and if you just say like this repo is 80 secure, I was like, I don't care what the number is, but you're just like, oh, okay, does that meet my bar? Like I don't know, like where's my threshold? Also, just the fact that we're talking about it, because sometimes people are just like, it's cool, I'm going to fork it and use it because as an open source maintainer, like I also feel the weight of the rest of the world vibe coding to like throw things at me, right? Like what's the book Building in Public is like the main thing that's hard about open source is the maintainer's time. Like that's the only finite thing we have. That's evaluation, by the way. That goes back to the evaluation bottleneck, which won't go away. And I think that it's just getting harder. Like when somebody can vibe code 4,000 lines and they don't have the same ownership over that. They don't have the context and they don't have that ownership. They don't have that relationship with the painstaking time that it took to do that. And then people people say, well, open source is how you get a job. So people are just vibe coding stuff and sending it up.
I need my GitHub graph to show all the greens.
Which is really hard because it's like there are people that genuinely want to do good work in open source and they can't get a chance. And we've already had struggles of how do we get new maintainers and new contributors into open source. And this is just going to create that next hurdle.
There's so much noise.
Well, this is tying directly back to the juniors not really knowing what they're doing.
That's why
there was a study done.
So exciting because you actually think about these things. Like you are the first CTO I've ever seen talk about AI in an honest way, which makes people want to use it because you're not presenting it as this black box of magic. You're like, it's not perfect. This is how you can use it. So like, I can buy into that, right?
Yeah.
I can't buy into the magic black box that like does all the things and never does anything.
What kills me, I'm sure you both have heard this, is the flex of, I don't even look at the code.
Yeah.
And I'm like, that's not the
flex. That's not exactly what this podcast is for. They fuck around and find out. Like, have fun.
And what you said about the GitHub squares is true. Like, how many dudes do you see on the internet and they're like, look at my GitHub. It has a million like green squares. And I'm like, but did you actually do anything that was helpful or that was like, you know what I mean? Like I can write a bunch of lines of anything.
Well, this is the metric that we've traditionally used to show developer productivity is commits.
Yeah.
And actually, it's like, this developer has a lot of commits. This one has, which by the way, I mean, you can look at it and go, that's not really, one commit is like I fixed a comment. The other one is like I checked in a whole piece of functionality.
Yes.
But now AI is like commit after every little step it takes, it's committing and pushing. And so if you take a look at AI commits, like it's dwarfing everybody else and like, see, look at how productive we are now with the AI and its
lines of code and all that. Man, this was probably like 2012. I found out that like the GitHub graph, it's just looking at a date in any repo and you can fake all the dates. And so there's generators that'll like write your own.
Right,
So I literally, when I was looking for a job, I put for hire as like my GitHub graph, said that in ASCII art basically across so I just had to rewrite that every day of like, for hire. So like maybe someone will see it and give me a job. And it's just like game that, any metric can be gamed. And so how do we make sure that it can be maintained in some way that is reasonable? Like, is this metric good or not, or is it effective at?
I think that's like with everything, like DevRel and everything. People are saying that DevRel is dead, but it's like all the things that are hard to measure, Like, I think it's funny, like people will do anything for gamification. Like I got the Fable app and it like sees how many books you read and it tells you like you're gonna like not be on your streak. Like at Amazon, we gamified the pipelines and I've never seen so many green pipelines in my life. Like people were like just sitting there like they were gonna get it like hours later, and it's just amazing. Like it's kind of like what I like was talking about today. Like human psychology and like engineering are so coupled in ways that we don't think they are, and like ignoring the human aspect is like so disastrous. And we do it all the time.
I mean, the open source side, like I think of any major hack at like a lot of places in the news, it all starts like social engineering, right? It's like go to the weakest leak of like, that person is just like at a bar and they're lonely and you can probably get the key card or password.
I feel like
or whatever.
I go to like all these talks and then there's always some dude who's like, but what about the technology? And I'm like, yes, but we've always tried to solve that. And you can't write a good technical solution without thinking about your users and what state they're using it in.
And maintainers, as maintainers are getting more burned out, they're like, hey, I would love to help. Like the XZ vulnerability from last year.
And that was a long
It was a long game, right? That was,
what I mean?
They played that well. And
it was dedicated. Like, and just the way that they wrote the binaries, like it was not only like a wonderful technical Trojan horse, but they went and found a project that they knew was used. They found one that had one single maintainer. They committed actual help for a while. You know what I mean? It's very, and I think that we are in just for like a world of interesting cybersecurity in the future.
I think so, in the very near future.
Yeah.
It's not gonna get easier. I know that much.
It's
I don't
so
know
interesting.
I don't know. A couple things. Anthropic again. They had Claude look at a bunch of open source projects, found 500 vulns in just a few hours with a few $1,000. They went and worked with Mozilla and found a bunch of CVs in Firefox. It was one of them. It's written in Rust. It's one of the most hardened, secure systems in the world. And Claude went and found like 12 new CVs in it. So the deluge is coming. And that's one of the things I'll talk about tomorrow.
And coming all the way back to your book, like 0 day, like not having a manual way to get around the thing, by relying on this so much and then not knowing how it works or how to turn it off or how to work around it, where do we end up in the next even 5 years?
Yeah. I don't know. And I don't know if there's a way to stop it. I mean, you hear the stories about the, law office and the computer goes down. Well, they're dead, right? Because everything is on the computers.
Yeah.
Already we've reached that point of, and we talked about some examples earlier, where we reached the point where computer system goes down and that's it. By the way, just for me, I can't code anymore without AI. I cannot.
You're at the point where it's like, I don't remember how to do these parts.
It's it's just a total waste of my time now. I'm just not going to do it. I'd rather wait the few hours for the system to come back than waste my time typing in code and doing the hard work that I used to do because I had to. And actually a lot of the, give it that, the Wordle stats extension. I couldn't do that one, because I don't know React and Node and if the AI is not there to help me, I'm dead.
And even then, I mean, you don't know the syntax, but you know what you want to do. Yeah. And I built this backpack over here for scale that runs a Kubernetes cluster in it, and people keep asking, how long did that take you to build? And I'm like, you know what? It probably took me about 10 years because I've been learning every skill. I was like, the actual putting it together, it was a few hours. It really didn't take, I vibe coded the app in it. I plugged in some things, but I knew what it was capable of and I knew where I wanted to go with it. And so over the last 10 years, I've learned the skills to say oh yeah, I can finally implement the thing that I wanted to do because I know the limitations.
How long do you think it's going to take people to catch up to the thought process that you're having with the pipeline and how we're not just going to have AI build everything? Because we're literally watching it happen in real life where they are just absolutely laying off tens of thousands of people saying that AI is going to do everything. What do you think is the line in which people are okay, maybe we need to start being more realistic? We've seen tons of outages. We've seen how it's gone. What do you think is going to be the reckoning, I guess, or for us to start actually creating processes in which to have humans and juniors and AI work together?
So in the worst case is that it becomes a crisis that wakes everybody up and to try to solve it together, because it can't be solved by Microsoft by itself. And that crisis is crap. Our seniors are retiring and we have nobody that understands how to run our system or evolve it. And AI can't do it by itself. And the juniors with AI can't do it, even if we hired them.
We've lost so much tribal knowledge that's not being passed down.
So that's the worst case scenario. And, me and Scott starting this, and we're talking to a bunch of schools about what it would take to scale a program like the preceptorship program across a bunch of companies and universities.
How do you do that in actual corporate America today, though? How do we change the engineers that are actually working at these big companies, the junior engineers, the mid engineers, the senior engineers? How do we change the way that they're working so they're still learning? Because even when you get into a company, right, there's still a lot when you're 1 year into engineering versus 3 years or 5 years or 10 years. There's so many different milestones and kind of different levels. What do we do in corporate America right now,
Well, at Microsoft, we've got a pilot of this thing going on in Azure. It's a small scale pilot because we're trying to just learn. But I think, every company that wants to participate in growing juniors has to, I think, is going to have an apprenticeship type model. Mm-hmm. But I'll tell you the other thing too. There will be a lot of places where they won't do that because they don't have the skills, they don't have the scale, they don't have the incentives to do it. So I think this is why structurally society needs to support it. And if you talk about, I think you were talking about tax credits for or incentive, government money to support apprenticeship model. That's going to has to happen, I think, to really support this. And it's going to to be, at the government, that's basically society saying, we're going to have a big problem unless we
at the end of the day, people have to tell people the government, this is important. I mean, think of other industries that had these problems, right? During COVID, right? The nursing shortage and teachers, everyone all of a sudden said pay teachers $1 million, right? My kids are home with me all day now. Teachers should make more money, right? As a society, we hit this point of this is an emergency and we need to incentivize it better.
That's why I think it's interesting that you and Scott, who are very, you have a lot of influence, are saying and coming out and saying it, because there's so many people who aren't saying it. They are just completely pretending it doesn't exist. So I think that's such a competitive edge that it brings to Microsoft, because if you are the only big company, I don't know if it is, but I'm saying like theoretically, that is actually thinking about that pipeline issue, that puts you miles ahead by the time everybody else figures it out in a like crisis.
And to some degree, it's just thinking long term, right?
Yeah.
Like this is just like, hey, Microsoft isn't here for a 5-year. We're just going to burn a bunch of cash and be gone, right? Like Microsoft's like, actually, what does it look like in 20 years?
Yeah,
like,
I think that's important though. Like we're talking about the strategy of like technology, and people are like, AI is going to fix everything, and I think it's going to be interesting when the winner is the person that thought about the human. And like we're like as engineers, like we come up with names for everything: Agile, Scrum, like DevOps, but nobody's thinking about how we take this wonderful new tool but make it like a process, and how we use that process, and and I'm just like, we use processes for everything. Like this is what we're not going to do it for. So
what does the marathon of AI look like?
You know?
Right? Like it's not just the next 6 months.
Exactly.
Do you have any closing thoughts on the security or the AI aspects of where we might be even at the end of 2026? Like this is it's all moving so fast.
Well, I think a few things on the AI threats with security and on the AI impact on hiring. The world is starting to recognize it. Both of those. I think these studies from these reports from Anthropic and what we're going to see is threat actors finding vulns in software at a rate that's going to continue to accelerate. And we're already starting to wake up to the fact that that's been happening. As far as the impact on juniors in the talent pipeline, you're already started seeing this over the last few years, and that seems to be accelerating as well. Yeah. With companies announcing that they're not hiring juniors, or job trending data showing that juniors, especially in software engineering, aren't being hired out of school. But senior hiring remains strong, has even grown in a lot of places. So the effects are becoming visible, and I think by the end of the year, there are going to be a lot more people. Scott and I started talking about this the early fall of last year. We were one of the only voices, but now you're hearing more and more people starting to say,
sounding the alarms for it.
Things are going to happen. So I think by the end of 2026, it'll be recognized as a problem by the mainstream.
Sure. Yeah, makes sense.
How did you find time to write novels and technical books? And like, what interested you into writing like novels and kind of, it's about technical things, but it's like a legitimate novel and more than one.
Yeah. Weekends, evenings, breaks, they kind of stay before work, kind of what you would expect. And that's whether it's writing novels or now I'm AI assisted coding. I won't call it vibe coding because I don't want to cheapen what I'm doing.
Yeah.
But that's what I've always done my whole career, is find time to do these other things while I'm doing my mainstream, my mainline responsibilities.
I know we don't have a lot of time, but could you kind of tell us a little bit about your career? Because I think it's really cool that you just seem to genuinely want to like figure things out, like in that you still stay technical in coding, even at this level.
Yeah. So got into computers when in 8th grade, when a friend of mine, their dad brought home an Apple II from this university they worked at. And he said, "Hey, do you want to go play on it?" And that night, that was it for me. I'm like, my future.
Got the bug.
Yeah. And then I wanted to learn as much as I could about the internals of computers. So I went to school and got a degree in computer engineering, got a PhD in computer engineering because I just wanted to go as deep as I could with learning. Went out, worked for a few companies, got into Windows in my PhD program and postdoc, and started to find problems with Windows and pissed off Microsoft, and then started a software company selling freeware software, this internal stuff, teaching Windows internals, writing the Windows internals books as part of that. And then he actually started writing Zero Day back in the early 2000s, and then got acquired by Microsoft in 2006 to go into Windows, work in Windows. So I worked on basically the Windows 7 was the release that I was part of, and kind of setting Windows
as
up
like
for
an
the future.
engineer.
Yeah, as an architect in the core operating system team. In 2010, saw the writing on the wall about cloud and realized a huge opportunity there to have a big impact, and joined Azure, which at the time was just a few hundred people at Microsoft, and nobody, basically the industry didn't know
the
what
Windows team was like, whatever.
Yeah.
Sure.
Yeah. And then that's where I've been since in Azure since 2010.
Well, thank you so much for coming on the show. It was great talking to you. And we will put the link to your live stream from Scale for the keynotes in the show notes. So when this episode comes out, people can check it out there.
We should put a link for the paper too.
Yes, we will put a link for the paper and also put a link for Zero Day in the books. So thank you so much. And we will talk to everyone soon.
All right. Thanks, Justin. Thanks, Hanno.
Thank you for listening to this episode of Fork Around and Find Out. If you like this show, please consider sharing it with a friend, a coworker, a family member, or even an enemy. However we get the word out about this show helps it to become sustainable for the long term. If you want to sponsor this show, please go to fafo.fm/sponsor and reach out to us there about what you're interested in sponsoring and how we can help. We hope your systems stay available and your pagers stay quiet. We'll see you again next time.